I think what we will hear today is really looking at the policy opportunities and challenges presented by an AI-enabled energy systems and the underlying connectivity that will help countries leverage the digital and green transitions in support of climate goals.
One pillar of that recommendation does look at the environmental impacts of networks. So we have a principle to minimize this negative impact by, one, promoting smart and sustainable networks and devices, and by also encouraging operators to monitor and to report on the environmental impact of networks, because we can only improve what we measure.
We have many examples of the positive impacts of AI technologies in supporting the transition to cleaner and also much more efficient energy grids and communication networks, digital twins, and we have Michel Morvan in the room. Smart cities and connected devices are all very exciting examples that are actually implemented in many cases, and we'll hear more about those today during the panel discussions. But what about the negative impacts of AI? What are these? And this is an area that can be difficult for policymakers to make informed decisions because there's a dearth of data. The OECD AI principles were established in 2019 as the first intergovernmental standard on AI. I think many in this room are aware of those. And they promote AI that's innovative and trustworthy and respects human rights, democratic values, and sustainable development. The sustainable development is an important component here. With Principle 1.1 stating that AI should benefit people and planet.
The ICT sector is responsible for between 2 and 4% of global greenhouse gas emissions, and if left unchecked, these will account for up to 14% of global greenhouse gas emissions.
Daegu Technopark is a specialized institution that implements the Daegu Smart City vision and strategy. Daegu is the third largest city in South Korea with 2.4 million people. Their main industries are machinery, automobile parts, ICT, and textile. Daegu has long been the center of Korea's industrial innovation, independence, and ideological experimentation. It was the cradle city of the supplying talents that lead the industrial economy in Korea. However, Daegu is facing diverse problems like other older cities, such as increasing risk, aging infrastructure, complexity of the economy, carbon natural problem, and so on. City leaders must satisfy the demands of the citizens using limited resources and budget. In addition, we must respond effectively to problems in the near future, such as the climate crisis.
Today, we have control on our loads. We can adjust our thermostat, for example, to go colder at night. Solar may be something of interest for my home. Self-generating my own energy. Should I use this energy for myself? Should I resell it to the grid? Should I store it? Should I use the storage against a future blackout? Or should I use it for economic dispatch or save CO2? Now, electric vehicles. As millions of electric vehicles will enter our life in the next 10 years, and 90% of all EVs are charged at home. Even our mobility, the fuel for our mobility, will be a game changer.
One of the main issues that we are collectively facing is this increase of complexity and the fact that decision makers, in particular in the energy sector, but not only, they have to make decisions in this extremely complex environment. That's where what we call digital twin arrives, because you create a twin of your system. It can be your electric grid, it can be your city, whatever, and you know its state in real time. That's what you can do when you have a digital twin. you can put the rules, the evolution, what happens, you can put that in a model that you call a simulation digital twin, and it allows you to simulate and to have visibility on the future.
There are three crucial key points for a VPP, realizing VPP. The first is localization, local fit of VPP. To increase the renewable energy, it is important to training prediction AI to fit each country's weather condition, weather characteristics. One country has much more chance of rain, but another country probably not. The second is acquiring good quality learning datasets for forecasting AI. I mean that the sensing data and the operation data should be good enough to learn AI accurately. Actually, we are talking about a data quality for AI in data mining and machine learning community from 10 years ago or so. Yeah, some countries might need to change the related laws to do so. I think it also led to decreasing calculation cost. The third is being economically and environmentally sustainable. I mean, this kind of activity can be continued only if we keep economical merit as well as environmental aspects.
So, Vodafone Business, we are piloting a new service called My Farm Web. We demoed in Mobile World Congress this year. This could help the acceleration of digital farming across Europe by providing our farmers an easy-to-use mobile app that can control the assets in their farm as well as the animals. We're piloting that in 5 European countries, so Germany, Ireland, Italy, and Spain. And what the app and the platform allows is it allows to store, visualize, and view the information gathered via agriculture, Internet of Things sensors, and other data sources in the field. So it collects data from the farm to support making decisions for a better soil and crop health, effective water use, and precision fertilizers and pesticides applications. So all of that will help and has the aim, to reduce the greenhouse emission.
The forum today has been both insightful and timely. It has highlighted how energy sustainability and security are increasingly of concern for governments around the world, for which innovation and digital technologies such as artificial intelligence can offer solutions. For connected smart cities to AI-enabled energy grids, governments, companies and households are ever more aware of the importance of leveraging digital transformation for a green future. We call this, as we already heard, the digital and green twin transition.